Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the chapter Magnetism and Matter, and you should have somewhat good knowledge of the magnetic field. Okay students, so let's go through the question and let's solve it. So see, the free space inside a current carrying toroid is filled with a material of susceptibility, this one. The percentage increase in the value of magnetic field inside the toroid will be how much here? So remember that the toroid is always looks like this, okay, just like you can see here the circles are there. So what will happen that here in case of toroid, what will be there? Here there will be the one conductor will be there, current I, and after that in that like this it is the toroid, okay. Because of the toroid, because of this kind of coil, what will happen that here the which kind of magnetic field will come? Concentric magnetic field lines will be there. Which one, students? Here it will be the concentric magnetic field lines here, okay. If I draw here like this, you see, now roughly I am drawing here, this is the magnetic field here. Because of the current inside, what will be this like this concentric magnetic field will exist, okay. So here let me write here, let's check here first. In case here air is there, what is this air? So remember that here for air, first situation, or for air remember that here this magnetic field B naught, what is the value? B naught. This B naught, remember that the formula used to be like this, mu naught Ni, okay, and this Ni, N is used to be number of turns by 2 pi Rm. And what is this Rm? Rm is called here the mean radius. What is this mean radius? Let's take here inner radius is the inner radius. Let's take here this R1, and let's take this outer radius is R2. So remember that here this Rm is given by R1 plus R2 by 2. Is it? That I am telling you generally. Now this is the magnetic field inside the toroid value. I is the current, okay. Similarly, let's take here in second situation, we have filled some magnetic material. Now free space is filled with a material. So what is happening at here, students? Let's take here we have filled here some magnetic material. Now so first let me draw here the coil here. So see like this here, let me draw here now like this. Second situation I am doing here, second situation, okay, and here like this it is going here. This is I, and this is also I is there. Now what is happening at here inside we filled some magnetic material inside here. What is this some magnetic material we have filled here, okay. So because of the magnetic material here, you can see what is present here, students. Material is present. Which material? Magnetic material, okay. So in this situation, remember that here for material, any specific material, now the magnetic field will be B, okay. And this we can write here, this is given by mu into Ni. Now mu naught is the permeability of the free space, and this mu is the permeability of the material, okay. So this mu we can write here mu naught into mu R Ni, okay. Or we can write here, see, this is the mu R, and here it is given by mu naught Ni, is it? So hence we can write here this B is given here mu R into, and what is mu naught Ni? You can write here B naught here, okay. So in new situation, this magnetic field B is given here mu R into B naught, okay. And if we see the question, magnetic susceptibility is given. The magnetic susceptibility means JEM, it is given here 2 into 10 to the power minus 2, or we can tell 0.002, okay. Definitely it is the paramagnetic material, not a ferromagnetic or not a diamagnetic, is it? So I hope so. This is the very clear to you, students here. JEM, this value exactly I don't remember, but definitely it is not a ferromagnetic material. It may be dia or it may be para, depending upon the JEM value. So okay, anyhow this mu JEM value is given now, okay, great. So students, if I write here the percentage increase in magnetic field, percentage increase in a magnetic field, okay. So what is the formula? Percentage increase in magnetic field is given here, see, B minus B naught by B naught into 100, is it? So we can write here, see, B by B naught minus 1 into 100. Now I have understood very well. I have just got it. As magnetic field is increased somewhat value, that means the material that we have filled inside the toroid, that is the paramagnetic material. Okay. Later in this chapter, you will see some specific values of mu r is there. Based upon that, we can get which material dia, which para, which ferro, and all that. Okay. So B by B naught here. So you know very well here. If I write here, this B is given here as I have taught you. B is given here mu r into B naught. So what is B by B naught? You can write here mu r minus 1 into 100. Okay. Up to this is clear. Now remember that here this mu r value is always given by 1 plus JM minus 1 into 100. Mu r value how much here? 1 plus JM. So what will happen that here? 1 and 1 will cancel out. It will become here JM into 100. Okay. JM into 100. Now students, after that see here the JM value how much here? 2 into 10 to the power minus 2, and here anyhow this 100 10 power 2 is this. So this 10 to the power minus 2 and 10 power this 2 will cancel out. How much coming here? 2. That means answer how much here? 2%. Is it? So what I have told you, in first situation air is this magnetic field B naught. In second situation we fill the material, it is the paramagnetic, magnetic field somewhat increased. Magnetic susceptibility, it is JM, and relation between mu r and JM how much is this? As I am telling you what mu r equal to 1 plus JM. Remember that here. Okay. So what is coming here? 2%. Let's check here the options. Any options are 2%. So see here the correct option is here option C. Is it? First one air, and second situation this material. Okay students, so I hope so this video you have understood very well. Keep studying, keep growing.